Hi, this is Barry Coombs from virtualizedreality.com and ComputerWorld. I'm a vExpert and blogger, and today I'm joined by Boris Wiseman of Datrium. Datrium, a new storage player on the market. Obviously, the storage industry is full with various different vendors, so in this day and age, you've got to have a reason to be different and to be able to win. So hopefully we're going to learn over the next 30 minutes or so why Datrium are different. First of all, Boris, would you like to just introduce me to yourself, maybe give me a bit of your background and what brings you to Datrium?
Sure. My name is Boris Weissman. I'm a co-founder of Datrium, a storage startup based in Sunnyvale at the heart of Silicon Valley. As far as my background goes, I've spent last 17, 18 years working on various infrastructure projects. And prior to Datrium, I was a principal engineer at VMware, which is quite relevant for Datrium. And I worked on a variety of projects there, starting from the first ever SMP virtual machines going back to 2001, 2002, on to Opteron and 64-bit hypervisor, and beyond that, hardware virtualization, and beyond that, fault tolerance, and a bunch of other projects. But basically, I spent a long time working on the core hypervisor technology. And VMware has roots in that as well. It created the technology, and of course, Datrium, to a large degree, benefits from this experience. And I left VMware in 2012 to start a company called Datrium with 4 other founders. Some have similar background to mine, going back to virtualization, and others are storage people. And Datrium is unique. Part of this uniqueness is the combination of the two worlds. When you look at the roots of the company and when you put it in the historical context, as we get into the details of the architecture, I think it will add some color and perhaps will be an explanation of why things evolve the way they have.
Fantastic. And I think your story, not whilst working for the vendors, is much similar to mine in the way that I've come across and I deal with storage. It's from a virtualization background. I started to look at storage because of the necessity with the way virtualization was going, needing to provide shared storage for the first time. I didn't really have a need prior to that to deliver any form of shared storage. And I think that resonates quite a lot with the people that I speak to in my job and also from a blog, that you do get some of those people that are storage people through and through. But a lot of people are now only looking at storage because there is some virtualization technology there. So certainly your background resonates well with me, and it sounds like it's also going to fit into Datrium and what you guys are doing there. So I suppose without any further ado, why don't you give us kind of the background, why you felt the need to go and co-found Datrium, and what makes it different out of all the massive players that are trying to vie to selling you disk at the moment?
That's right. So actually, that's a very good point. So my background is more of a core hypervisor, and I fell into storage more or less by accident. My last project at VMware was applying virtualization technologies to try to run transactional databases better. And as a part of this, we had a testing farm. And even though I worked on virtualization forever, just as you, I've discovered that at the back, you have to have shared storage to actually do it in production. And at the time, so it was around maybe 2010, 2011, so it was an eye-opening experience. We actually had industrial strength storage, mid-range, but the realization came that these expensive systems that would cost us hundreds of thousands of dollars were actually less performant and more rigid than a little system which is put together in the lab that could run our, test and their workload about 5 times faster at maybe, a small fraction of the cost. And so my partner and I at VMware, we both worked on the project, and we realized even that when you look at the modern data center, compute is very different now from 10, 15 years ago. Now, obviously, also server workloads are virtualized. Network has evolved quite a bit. But underneath all of that, there were still rigid old legacy arrays that have been designed, 20, 25 years ago for a completely different world. They have been designed for, file sharing, for workgroup servers, for, database workloads, and yet they were repurposed later just to run your complex virtualization mix. So even though we were quite able to run our own workload and our homegrown system, the actual industrial strength array was giving us trouble all the time. And it was also hard to manage. So we ourselves were not qualified. We had to use a professional storage administrator to run it for us. So we realized that storage was in fact a bottleneck, both for performance reasons as well as cost reasons. So we left in 2012 to try to address this problem in a different way. And very quickly it became apparent to us that we probably would end up with some kind of a hardware appliance. And both of us were software people, so we realized that we needed to learn how to make and support storage appliances quickly. And as we were making our rounds, trying to gain new experience, because the problem itself was apparent to us, that's what we wanted to do. We were system people, there was a system problem, there was no good solution, there were plenty of opportunities for optimizations. As we were making our rounds, we were discussing this problem with Diane Green once at a coffee shop in Palo Alto. And we said, suddenly we need to get retrained into this world. And she said, well, let me help you, because I happen to know a couple of storage people who don't need retraining. They already understand, that domain quite well. So she made an introduction to Hugo Patterson and Brian Biles. Brian was the founder of Data Domain, which was a very successful backup appliance company acquired by EMC. And Hugo Patterson was a chief architect and a CTO of Data Domain, and subsequently an EMC fellow. And they were in a similar stage, trying to understand how the landscape has changed, trying to start a new gig. And so we met. We had very complementary skills. We wanted to solve the same problem. Even though our architecture is a bit different from what you find out there, we pretty quickly converged on what we actually ended up building. So, that's sort of the historical context. So, and somewhere along the line, we were joined by Sazala Reddy as the fifth co-founder, who was also a storage architect from Data Domain. So we are unique in a way that we combine in one company the two worlds, the virtualization world and the storage world, and we have a purpose-built system that uses the best of both worlds to solve the problem in the most efficient way possible.
Okay, fantastic. So certainly lots of big names there from lots of different industries. I think you mentioned obviously Diane Green being one of the co-founders from VMware, and obviously then the background from all you guys from Data Domain. So lots of good companies coming together from a kind of software-defined world, but also more a traditional storage world. And from what I've dug into, that probably sums up your technology quite well as well, that you're not coming at it from one angle. You're looking at the way that multiple different technologies are being used in the industry today and creating your own version of how a hybrid should work, rather than just a lot of vendors are just gelling together SSDs with spinning disks and that's their hybrid technology. You're tackling this from a completely different angle as far as I can see.
Yeah, that's correct. So from the beginning, it was obvious to us that the old shared storage solutions, SANs and arrays, were too rigid for the new environment. So we needed something that would actually scale as the workload scale. And we needed this scaling to happen more or less automatically, magically, without having to provision new hardware or to do very careful planning of your future workload needs. So that was obvious from the very beginning. And at the same time, we did not want to dismiss old arrays completely as new software-defined storage, some new storage solutions do. In particular, we found the management abstraction quite useful. So we think storage, especially if it has gravity, we think it needs to be managed in a slightly different way from traditional compute. So while the implementation may no longer be adequate, I think the abstraction of treating storage in a different way, in a special way, and applying special storage management techniques to it, that still holds. And around 2012, so that was around the time when Hyperconverged sort of emerged as a new category. And in particular, Nutanix and SimpliVity exited stealth mode, just much like Datrium is doing now. So we knew about that development and we welcomed it. And, so we were not in isolation. We welcomed it a lot because suddenly there was an alternative to arrays that was more flexible, provided some of the scaling aspects I mentioned previously. At the same time, we also recognize that while useful for some contexts and some market segments, that wasn't a solution that would completely dominate the storage industry in the future, mainly because of some deficiencies inherent in the model. For example, you cannot, in the hyperconverged world, you cannot independently scale compute from storage. It all comes together. You're locked into the appliance that you have. Economically, you end up paying your high storage level margins, not just for storage, but for your servers as well. So that's not that great. You don't have much choice. It's all combined together. You cannot provision your flash independently if you run out. You cannot provision your compute independently if you run out of compute. At the same time, but the huge advantage offered by Hyperconverged was, of course, managing storage in a simple way. So suddenly, you didn't just manage some artificial storage abstractions such as LANs or aggregates. Instead, you just managed your virtual machine. So for a person who runs virtual infrastructure, it was sort of a very natural way to manage storage. So that was actually great, and we welcomed that a lot. And of course, the scale and capabilities were awesome. So we looked at that as well, and we realized, okay, so that is useful perhaps for some environments, in particular smaller installations or remote offices, perhaps less useful at scale. And then we decided, okay, to rethink the entire architecture, not just storage, but compute as well, and figure out the solutions that would be more applicable, not just for smaller installation, but would have better scaling characteristics across a wider range of use cases. And this, in part, explains why we ended up with what we ended up. So if you look at the evolutionary step, so it's not just we decided to build something unique and unusual just because the storage market is populated by a great many startups, as mentioned. There was actually a reason to it. So we wanted to do something in a cost-efficient way, and we wanted to do something that has never been done before because the use cases have changed. So with that, perhaps I could jump into the DVX architecture, if that's okay with you.
Yeah, definitely. If you could maybe explain to us the sum of components and maybe how it scales and how that then applies to maybe particular workloads or where you see it fitting.
Right. There's a whiteboard. Okay. So, well, there is a whiteboard, but let me just try to talk through it. So if you look at DVX, there are two main components there. There is a hardware appliance. It's a simple appliance. It doesn't qualify to be called an array. It's a simplistic thing. It's commodity-based. It only provides shared capacity management, durable capacity management. It doesn't have most of the traditional functions that you find in the arrays, such as it doesn't do compression, it doesn't do deduplication, it doesn't do clones, it doesn't do RAID, it doesn't do a lot of things. The thing it does do is essentially providing durable capacity at a low cost. It also has, for write acceleration and durable persistence of storage, it has a little bit of RAM protected by the battery. So writes could be staged to the appliance quickly, and they're replicated for protection. And I guess the most important thing in the appliance is that there is no single point of failure. Any component of failing of any component is handled. If the entire controller fails, there is failover. But other than that, it's a fairly simple x86-based commodity system. And this is what we sell, and this is the only thing a customer pays money for. Everything else essentially arrives bundled with it. The other component is our software that runs both on the appliance and outside, inside the hypervisor. The software is called Diesel, which stands for Distributed Execution Shared Logs. It's a distributed file system which is purpose-built to handle virtualized workloads. And the interesting part is because it was created to run partially inside the hypervisor, it can benefit from understanding the virtualized environment. On the hypervisor, it provides several functions. It does performance accelerations. All the CPU-intensive operations, storage operations now happen outside of the appliance. They happen inside the hypervisor, so we remove the bottleneck. And by these CPU-intensive operation, I mean compression, I mean deduplication, orchestration of snapshots, even RAID computation and RAID rebuild all runs inside the hypervisor.
Okay.
Also, our appliance, as I mentioned, it's just a simple appliance. All it has is cheap capacity storage. It doesn't have any flash in it. It has just 12 drive bays for fat SATA disks. All the flash lives inside hypervisor machines, and our Diesel software manages that flash. The interesting part is because we use flash basically for acceleration. It's a cache. At the heart of it is just a cache. And the durable storage is elsewhere. It allows us to, use cheap commodity flash, consumer flash that is kind of uncommon in the arrays, because for us it's not a store of records, there is really the copy of the data elsewhere. And that actually brings the cost of flash dramatically by at least an order of magnitude compared to array-based flash. Secondly, we don't sell the flash. You can buy it to satisfy your needs as your workload needs change or fluctuate. You're certainly welcome to buy more flash and install it. There is no cost to it. We support up to 8 terabytes of flash. And if you factor in data reduction such as compression and deduplication, looking at the industry standards for primary storage, you probably should count on somewhere between 2 and 6x data reduction. That brings your flash per host, effective flash per host, up to 48 terabytes, which is actually huge for a single ESX server, for example, right? And combined with a relatively low price, also counting data reduction, our cost of flash to end customer is somewhere between 5 and 10 cents per gigabyte. So it's almost free. So at that cost, you don't really have to carefully plan your workload evolution. You can just spend a few $100s and buy an extra terabyte of flash and not worry about storage for another couple of years. And that's pretty much the direction where we want our customer to move, because of the rapid drop in the price of flash over the past couple of years. It's cheaper now to massively over-provision these things and don't spend human capital trying to figure out just the right, inflection point that satisfy your need now, because the difference is, on the order of hundreds of dollars now. It's just not worth the time. So in short, Diesel manages local flash, Diesel software on the server. It manages compute. It manages memory on the server. We arranged it so that there is very little chatter between different hypervisors. A virtual machine running on the hypervisor generally uses the resources of that host and that host only. And that's a little bit different from the hyperconverged systems where they try to pool things together. And it has benefits, but it has drawbacks too. The main one is the general unpredictability. You cannot reason about a single virtual machine without taking into the account the load on other hosts and other virtual machines. So from the beginning, we decided to use physical containment and performance isolation and try to isolate virtual machine to the host as much as possible. The added benefit is if you have, for example, a busy database that does need a lot of flash, it does need a lot of compute, well, that's fine. You just put it on a big machine with lots of flash and lots of compute, and it will stay there and will not create any problems for anybody else. So those are the two main components. Combined with by your own flash, it creates a very different system, a system where your storage management sort of becomes more similar to your virtual machine management. For example, if you do have a performance bottleneck, either due to the lack of CPU or the lack of flash, well, you just vMotion your VM somewhere else when you have more CPU and you have more flash. And you can easily add hosts to clusters like this, and like Hyperconverged, because our hosts are stateless. There is no durable data on the hosts. Adding and removing servers from the cluster is the same as it always was in virtualized environments. And unlike Hyperconverged, there is no expensive rebuild operations when servers leave and join clusters. And this is because of the uniqueness of the architecture where all the storage lives on the appliance. So perhaps combined with historical context that explain why we ended up where we ended up.
Sure. So it sounds like you're getting a number of the benefits that the hyperconverged players are getting in terms of maybe getting the flash closer to the compute, which
Oh, absolutely.
presumably can improve your performance times. But you're getting a benefit of being able to deliver that on top of the server platform, the compute platform that the customer decides. So there's no need. We're not saying that stop buying your Dell, HP, IBM servers. You now need to buy Datrium servers or anything like that. You can still use
Absolutely.
your vendor of choice.
Absolutely. In particular, unlike Hyperconverged, we are very friendly to blades because we don't require 408 drive bays to put big disks in. All we need is 1 or 2 slots for flash. That means you can use your favorite blade vendor or any kind of server vendor you like, including small modular servers. So we are completely agnostic. You can stay with your server vendors. That's absolutely true.
Fantastic. But then obviously on the flip side to the hyperconverged message, a problem that I have seen myself, and I do a lot of end user computing, is the way that you end up scaling a hyperconverged infrastructure. You either, certainly in an EUC environment, you end up with too much capacity because you're constantly having to add capacity each time you're adding compute. And because you've got this simple shared resource that you're using for commodity storage on the back end, that seems to simplify the architecture, so we're not having to have maybe so many copies of the data around, maybe, I'm not sure. But also it means that we can scale as we need from a capacity perspective on the back end.
So that's correct. In fact, we don't copy, we don't replicate, because, and this is where we use technologies developed in the legacy array world. Unlike many hyperconverged systems, we don't have to replicate data 3 times or 4 times and whatnot. We actually have a more traditional rate in the back. There is 20 to 25% overhead for RAID 6, and this is what you get. Combined with data reduction, I think between, say, 2 and 6x, you can count on the effective storage capacity of the backend somewhere between 60 and 180 terabytes. It's for a single shelf, and could have more than one shelf. So that's actually true, and of course you can scale your servers completely independently from your backend. So, and also, as you mentioned, because flash is local, reads are served effectively from the local flash. They don't even go on the network. So not only you can scale your compute and flash independently, your pressure on the network is significantly less, because essentially what you see on the network is only compressed writes. Reads never go on the network. They are served from your local flash.
Sure. And in terms of protocols, am I correct in understanding that you don't use traditional iSCSI NFS fiber channel? You're using your own protocol, or have I got that wrong?
Yes and no. So as far as management goes, we appear as an NFS3 data store. So it's very simple to manage. You just mount us as any NFS data store. The only difference is that the provider terminates inside the local server itself. So we do use a private protocol for our own synchronization and communication, but that's not invisible to the end user. As far as the end user is concerned, you can use any vSphere or ESX tools for mounting and examining files. We are just an NFS server in that regard. So.
Sure. And in terms of the other side of it, we see lots of vendors that maybe have got the performance sorted, that have a very unique product, but then in terms of usability, management, monitoring, reporting, analytics, we see that lagging behind until kind of the second, third generation of a product. Where's your kind of ethos behind that side of things?
That's a very good point. So our first hire was, in fact, a tech lead on the system management component of the system. So as far as management goes, our management console is a plugin into vCenter UI. So you manage everything from a single pane of glass. In fact, we don't have any other UI. That's the only UI you get in our vSphere product, right? So it's completely integrated. You can see your virtual machines. You can see per VM performance for your virtual machines. You can see historical artifacts and historical data. There is also CLI on the appliance, but we don't expect casual users to actually ever have access to that. And as far as managing the appliance itself, well, because it's so simple, it doesn't really have any storage services, so there's really not much to manage. I mean, it just has 12 disks, and all the performance is handled outside. So by and large, performance management is not a storage operation for us. You manage your performance exactly the same way you manage your virtual machine, and the main tool, surprisingly, is in fact vMotion. You just vMotion your VM to a host that has resources. This is your performance management in most cases. So I wouldn't say we have the most elaborate management. Our goal to have as little management as possible and to have it integrated and be per VM. So we have no, other than virtual machines, there is no any storage LANs, or there is not much else to manage in our system. So.
Sure. In terms of kind of getting down the line of support and how you guys would support a system, I have seen systems before. I don't like to name manufacturers when I've got an issue per se, but where you were trying to mix manufacturers' components or software with hardware components that are supplied by someone else, you can sometimes get caught in the middle where the software manufacturer is blaming the hardware manufacturer and the hardware manufacturer is blaming the software manager. How are you going to sort that piece to make sure that your customers get that kind of unified support message from your company to take ownership of Datrium as a product as a whole?
That's actually a great question, and our architecture is in part an answer. On the appliance side, we take full ownership. We provide hardware, we provide software, so there should not be any question. If something goes wrong, we will provide our service to replace the components. And this is, in that sense, the support model is exactly the same as you have seen with arrays for many, many years. So that's a well-understood problem. Now, we do have a component, and this is where it could get tricky if you do it wrong. We do have a software component running inside the hypervisor, and we don't control, what kind of server that is, and we don't control what kind of flash that is. We don't necessarily prescribe what kind of RAID controller you have. And there could be tricky situations. So our answer was, whatever problem happens there, because we don't treat our servers are essentially stateless. So you should never get in a situation where your data is corrupted or unavailable because of these problems that you have described, just because servers are fungible. They're commodities, they're fungible. Even if you get into a state where it takes time to figure out what went wrong, it could be us, it could be something else, well, it doesn't matter really. You just move your VM to another server and life goes on because your storage in the background is protected. So that's one thing. Secondly, the system was built from ground up to deal with esoteric behavior of commodity flash. In particular, we have an elaborate system of checksums and integrity checks. So you should never get in a situation, it's not that unusual to have, because there are several hundred different SSD models on the market today. And some of them, there have been reports of data loss or data corruption from major vendors not so long ago. And so we built a system with full knowledge of that. So data corruption, data loss on the server side, because of our software integrity checks and checksums, we can always detect it. And because we always have another copy of data in a protected environment, assuming this data corruption and misbehaviors are episodic and not systemic, it's a little bit of a nuisance, but you can always get another copy of your data from the appliance. So in that sense, the system is built to actually work with SSDs that do fail. And the failure, and you can put as many of them as you like. You can put up to 8 SSDs in a single server. So if 1 or 2 or 3 of them fail, well, you can still continue operating. And so other than that, we do require that the servers be on VMware HCL and controllers to be on VMware HCL. So, you may have, if you have a issue with the server, you will have to contact your server vendor. We don't do anything. We don't use, we only use private APIs. We don't believe we increase the complexity of the system. So I hope that addresses some of your questions. We do collect support bundles from every component that runs our code. They're shipped back to our bundle processing centers. So we have visibility into what's going on in every piece of the hardware and software that we manage. So in that sense, our goal is to provide similar experience that you would expect from the high-end array vendor and not make things any more difficult.
Fantastic. No, that answers my question. Thank you. So I suppose from the other side, at the moment, you're very clearly aligned to VMware. I mean, if we look at your background, VMware is a technology that obviously is in your background as well. And I think that that's a strategy that certainly Nutanix and others have picked VMware as the market leader to start with. does your product scale past VMware at some point in the future? And I appreciate it's very, very early days for you, but we're seeing kind of KVM starting to make more of ground, particularly with OpenStack and things like that. Hyper-V is always in the background, or do you see yourselves always aligned to VMware?
Yeah, that's a great question. Obviously, we want to start with VMware because A, this is where our strength and our experience is, and we could probably do the best jobs there just because of the roots of the company. And it doesn't hurt that it is absolutely the market leader in this world. So that's our starting point. That said, even our internal testing runs sometimes on bare metal Linux. So clearly we have our eyes on other hypervisors. So while we believe that virtualization is there to stay for a very, very long time, the architecture is not necessarily targets a specific vendor. And, obviously VMware is our great friend and partner, and this is where we go first. This is not necessarily the only destination, and we will address all the other hypervisors over time, as you mentioned, and as the customer demand materializes.
Sure. So from a perspective of specific use cases, are you aiming your product at specific use cases, specific sizes of customers, or is it kind of a scalable solution that can go from the smallest SMB VMware Essentials Plus installations to the biggest cloud data centers? Where do you see yourself in that piece of the pie?
Right. So we're obviously a new vendor, so we need to start at a modest scale, and going after this sort of well-defined mid-range market is where we go. As we get more experience, we'll get exposed to more environments, but we don't necessarily see ourselves as targeting a specific workload or a specific scale. It takes time, as you know, in storage to prove your reputation. I think over time it will be good at a wide range of, and this is our strength, the strength of our architecture. I think we will be quite good at a wide variety of use cases and workloads. We will start small, we will grow bigger over time. We hope that the architecture is flexible enough to carry us forward for many, many years to come.
Fantastic, brilliant, thank you very much. So just to give people that may be watching this video an understanding of where you are today, understand that recently you've obviously come out of stealth mode, you're already working with some customers. Where are you on that journey at present?
Right, so we exited the stealth mode and launched the company a couple of weeks ago. We have a dozen beta customers. Some of them are, we have customer testimonials on our website. In fact, our alpha shipped over a year ago, so we had units in customer hands for over a year now. We will continue that. As you know, it takes time to build a reliable storage product. So we are probably within 6 months from actually delivering the first version, and we will slowly ramp up our customer base from this point on.
Fantastic. And if people want to find out more about you, I take it you're on social media, website is a good place to look, I assume?
Yeah, absolutely. There's a website, there's a Facebook page, there's a LinkedIn page, there's Twitter, there's a 451 report, there's plenty of information. We used to be in stealth, we are not anymore, so please go to our website.
Fantastic. Any of you guys going to be at VMworld? I assume it's probably a bit early days for you guys to have a stand there, but are you attending?
Actually, we will. So we will, in fact, have a booth at VMworld. This is our coming out party, and if you're there, please stop by and say hi, and let's hope some of your listeners will stop by and talk to us too.
Fantastic. And kind of, I suppose the final comment, the customers that are currently trialing your units, what are they finding the main advantages? What is your storage system allowing them to do that previously they haven't been able to do with the platforms they have been using?
Right. So I think the most striking thing for them is the ability to bring their own flash when you need it. Well, let me give you one anecdotal example. So because of a probably imperfect schedule on our part, one installation went slightly wrong in the sense that our our engineers arrived at the customer site, and the customer didn't provision SSDs for the system. So they ended up going to a local electronics shop to buy a few SSDs. And, this is not something you can do with an established array, right? You would have to plan, and you'd have to buy new units. So the ability to add flash by just, making an Amazon order, so that's a striking difference. So that's probably one. The second one, the scaling of the system has, with a traditional array, as you add another server, you essentially subtract from the performance reserve of the array, because now some slice of the array is dedicated to the server. In our system, as you add another server, you actually increase the performance reserves of the overall system, because a new server comes with its own CPU, its own memory, and its own flash dedicated to serving storage. So this is sort of very different. If you're an administrator, it has a very different feel, because suddenly adding a server to the cluster actually increases your storage IOPS and throughput. That's sort of different. Sure. And I'd say those two are probably the main differentiators at this time.
Fantastic. Brilliant. So I think that's the questions from my side. Thank you ever so much for spending the time to have a chat with me. I think it's good just to kind of get that high level understanding. Obviously, people can go to your website to dig a little bit deeper, ask them more technical questions on social media, or bump into you at VMworld. It all sounds quite exciting to me, quite different, tackling a problem using lots of maybe similar technologies to what we've seen elsewhere, but bringing them together in a new hybrid fashion. So I wish you all best of luck, and we'll see in 6 months' time how you're getting on with that first release.
Thank you very much. Really appreciate you talking to me. Thanks.
Brilliant. Thank you.
Bye-bye.